Here in chapter 3, we want to look at the empirical tools of public finance, meaning we're going to look at statistical techniques used to measure the impact of what we're trying to do. Okay, so what that mean here is that we need to distinguish, obviously, between correlation and causation, which we'll both describe. As correlation, meaning that two variables move in some direction. Either they move with each other or opposite each other, but it's not that one of the variables changing causes the other to change. The best example of this would be is that you could say something like ice cream causes or ice cream consumption and death from drownings both increase, right? It's not necessarily that that eating ice cream causes people to drown. Rather, they're just both moving together because people swim more in the summer and they eat more ice cream in the summer. Thus, they're correlated, not causally related. As simple as that is, it's actually a pretty common mistake depending on the person who's trying to make an argument for one thing or another. And so we see this also. It's described in the book as well with the Russian peasant fallacy, the breastfeeding fallacy, and the SAT training fallacy. So, for instance, with the SAT training fallacy, it would be that people who prepare more do better on the exam. But what we also see, right, is that those who have more resources, right, those from a richer family are able to prepare for the SAT more in addition to other things. And so that rich families do better on the SAT because, in part, they can afford that extra training. So, what becomes important then again is distinguishing between the two, and we end up spending a great deal of time trying to inform people about what's going on. And again, that's just described right here. That correlation does not imply causation. I'm not sure why they decided to put it on an additional slide, but it is in fact true. And again, if we look at this SAT prep course now as a slide rather than just kind of my simple discussion here, is that if we look at Harvard students who took the SAT prep course, that that those who took it, in this case here, that those who took the prep course did not do as well. Now, is it the case, right? So if we look at this discussion here, is it the case that taking the prep course reduces your score? Is it the case that people who take prep courses are those who are just not good test takers? Or is there something else going on? Well, what we would have to do is to answer something like that, anything like that, we would have to start to create some trials. We'd need to separate out the group of individuals into groups, one of them being a control group, one where nothing is done to those individuals, and then the other being the treatment group, the ones who have the thing done to them. And then we're going to compare the averages to each other. I should also say, too, this is a randomized trial, meaning that individuals are randomly put into the two groups, the treatment group and the control group. So what do we see here, right, is that if the individuals are randomly placed into the treatment group and the control group, then any statistically significant changes in mean scores or whatever must be because of the treatment itself. So these randomized trials are highly touted, the gold standard for determining causality. We see these obviously with, especially with like medical drug tests and whatnot, where some individuals that are selected for um, a a trial for the use of a drug. Some are not actually are just given a sugar pill and they're put in the control group, and then some actually receive the drug and they're put in the treatment group. Um, we do have some bias, right? And this bias would be related to the fact that the bias would be eliminated by the fact that we're randomly placing individuals into the two groups. So you'd have to have something like assign everyone a number and then have a random number generator, place people into groups, something along those lines to try to create those control groups and treatment groups. And we saw this again with medical drugs. In this case, what does estrogen replacement therapy or ERT, how does that affect individuals, right? And what they had found that using a randomized trial that it caused increased risk of heart disease. So then people stopped taking estrogen replacement. That would be for like women undergoing menopause, for instance, so medicine. And then in public policy, right, with TANF, going back to the temporary assistance for needy families, is that randomized trials is that showed that if we change programs and how much they provide, then we can encourage employment. TANF being one of them, the other being the Earned Income Tax Credit, EITC. Now we do have some problems, right? Even with a randomized trial, we can still have some problems, and the problems would be is that individuals, um, if we're talking about a specific group, not even every individual wants to be part of a control group and a treatment group. So it's not necessarily the case that the conclusions we reach for this sample is going to extend to the population as a whole. And that what might happen is, especially with medical drugs, right, is that if the people in your control group aren't getting a needed treatment and are dying off, then you've got attrition. And that might be causing your sample size, at least within your control group, to get smaller. Okay. Again, in general, I'm just going to skip the learning by doing, just with the idea that you can do those yourself if that's the thing you want to focus on. Um, it's difficult sometimes um, to create experiments like this where you have a control group and a treatment group. So most of the time, what we try to do is try to collect a lot of data that's observational in nature to be able to um, imprecisely, but as best as possible, try to create conditions of an experiment. Um, there's going to be some biases involved, even just in collecting observations. And again, we're not going to know what all the other um, variables are that are changing. So again, it's why we say that randomized trials are the gold standard. It's difficult to have a perfectly designed randomized trial, though, which is oftentimes why we end up with a um, relying on observational data instead. Besides this, the other thing that we try to do sometimes is try to use time series analysis. So we look at how variables, how observations change over time, with the idea being that when something is changed, that we can see um, something else going on, something changing as some other outside force changes. And that would be again with our the striking thing that we saw when welfare was reformed in the mid 90s under the Clinton administration when the Republicans were in Congress, is that, let's just call them in general welfare, but we're just talking about all the social support programs. When those programs reduced um, their generosity. What we saw is that families facing starvation worked more. Now, we can clearly see here correlation, that families worked more, benefits went down, a negative correlation. But as even this last line says here, we don't necessarily know if that was causal. Obviously, those in favor of reducing benefits are going to say it's causal, and there might be strong evidence to suggest it is, but we don't know that for certain. Because obviously here, right, this just reflects the fact that people's labor supply went down because there was a pretty bad recession. Recession also here in the 80s. And a small recession here in the early 90s. The mid 90s to late 90s was a very strong economic time period. That could be a different reason why people ended up working more. And so that's what we then need to do here, is we need to describe those different time periods here. So that's what we try to do right here. We could look at the time period of 78 to 83 and 93 to 98 and see what's going on here. So let's do that. Right? In this case here, we could, if we use this time series analysis, we could look at how smoking rates change. Now, again, is it the case that smoking declined just because cigarettes were getting more expensive? Maybe that's the reason why we see this cause. Maybe they are causally related, which would then mean, right, that governments pose more taxes on cigarettes to cause people to do it less. But it could be a host of other things as well, right? People finally realizing the health consequences. It could be having less places to actually smoke. That's all causing these other changes of why youths are smoking. But I don't know. For me, if you look at this, that's a pretty significant achievement we have made as a society, right? If we accept the evils of smoking, look at that. It's now pretty rare to see youths that smoke, as compared to the popularity of it in the 70s. Which is why probably I find why people find it always so odd when I tell people I used to smoke when I was a teenager, but it makes sense, right? Because in those cases, I graduated from high school in 95. The smoking rate was pretty high. And it was actually pretty easy to get cigarettes, too. Like, you get them from vending machines and whatnot. They weren't that expensive. Yeah, we knew kind of about the healthcare risks, but, the other things, it was easy to access. It was relatively cheap. But then why did I stop? It wasn't necessarily the price. It just, I don't know how to describe it. It wasn't even necessarily the health effects. It just, I don't know, it became less cool. Yeah, and you wake up smoking, wake up coughing and whatnot, and that's not nice. But maybe that's the case too, right? It's just not cool to do it. Now, on the other hand, it's cool to vape, right? And so now if we looked at this in terms of vaping, we'd probably see something very different. So oftentimes what we need to do if we're looking at this, rather than just looking at this over time and just seeing kind of what's going on and looking at this from a correlation perspective, what we might want to see is to draw it a little bit closer and look at things causally. We might want to try to look at things from a regression standpoint. So if you remember from statistics or any basic statistics course, what a regression does is it tries to find the way in which two variables are changing with each other, either one going up, one going down, both going up, both going down, and trying to find what's the best relationship that we can describe between the two in terms of the magnitude of the variables between the two. So let's go back to our TANF benefits, right? And so if we look at this here, right, we could have, if we graph our points and we have our $5,000 TANF benefit, and then we reduce it down to $4,550, what we would expect is that labor supply would go up, as it did, labor supply of 0, then going to 90, right? And I'm just going to jump ahead here. We would see this right here and be able to estimate the slope with our linear regression line between the two, between how much does reducing this benefit cause the labor supply to go up, in this case by negative 0.2. How'd they get that? Well, when changed by $450, and it changed by 90. Right, which 90 divided by 450 is 0.2, negative 0.2, right? Because it's an inverse relationship between the two. Okay. And you can see that right here. Don't worry about the bivariate, just saying two variable regression indicates that for every dollar we reduce TANF benefits, that people work 0.2 of an hour more per year. So we can see here that this regression analysis is somewhat useful for understanding the relationship between these two variables. And if we look, again, it's hard to have a randomized survey here, but we can take a lot of observational data from the current population survey, which is a database that economists use quite a bit. And if we look at this, I'm going to skip over slide 24 here for just a moment here, but what we can see is that what the real-time data tells us is that every time we double TANF benefits, that people work 127 hours less per year. So if you're obviously facing constraints in your labor supply, that would be exactly what you would not want to do. And so this is what we see here. If we increase the benefits by 100%, then we reduce the work hours by 11% for an elasticity of negative 0.11. But if we look at that elasticity of negative 0.11, this is a pretty important point here, is that it's actually pretty inelastic. People really don't change their hours that much. I can double the TANF benefits and people only work 11% less. It's not people are getting lazier, it's just that they're realizing I can actually have a little bit of leisure time. I'm not, personally speaking, I'm not sure if that's such a bad thing. But that's, again, me personally saying that, not the data saying that. So what do we see here, right? Those who get the largest benefits work the fewest hours. Is it because they are consuming more leisure? Or is it because even regardless of whatever the TANF benefits were, they just like leisure so much that they would still consume it? We don't really know, right? What the answer is to that. So typically what we need then is some control variable. We need to try to control for the biases that exist. So we need to somehow try to find a variable that gives us, as from a shadow perspective, a shadow variable that tells us something about how much leisure people want. It's pretty hard to do. I don't know. There's not very many variables out there that would allow us to measure for leisure. Economists get a lot of money, though, to try to create some experiments, at least, related to this. And so then they would create experiments, quasi-experiments, where we give certain individuals a certain amount of things and we see what they do. We're doing this with things like the basic income, right? There's people out there that are trying to promote this idea that people just be given a certain amount of income and they'd be allowed to do with it whatever they want. And so they're setting up experiments to do that. Or what we do is we look at things where people do these difference in difference estimators. So we could find two states, for instance, that let's just say share a border. And in one case, they have reduced benefits, but the other did not. The other kind of classic example of this was one with Pennsylvania and New Jersey. One state raised its minimum wage and the other did not. And what they found was that raising the minimum wage actually had no impact on the unemployment rate. In this case here, between Arkansas and Louisiana, the benefit went down to $4,000 in Arkansas. And what we saw is that in this case here, that by reducing the benefits, a little bit odd here, but by reducing the benefits, people reduced their labor supply. Why is that? It could be in part just because individuals wanted to either qualify for more federal benefits, or they could have even simply moved to a different state. Those who were willing to work more and were more industrious just moved to a different state. Um, the other thing we can do here is look at this from a quasi-experimental standpoint. And so in these quasi-experiments, what we see is that we're never really sure if we've gotten all the bias out of our treatment group versus our control group. So what we try to do is we try to be a bit intuitive for the most part, and try to, if we're intuitive, we say that we've created an experiment that's removed most of the biases, or we try to use some various statistical techniques to try to confirm that most of the bias has been removed. And a lot of this also comes down to just how we structure everything, right? In terms of structure, how the benefits are delivered to individuals, the way in which we structure even just our measurement of things like labor supply and whatnot. And this all leads us to then making estimates of individuals' utility levels, how much of an income effect something is having, and how much of a substitution effect something is having. What do we say about this when we look at a slide like this? It's just an inexact science. I mean, in some sense, public finance is exciting because what you can do is you can be a person that's got strong beliefs about how the world should work and what your perspective is on people receiving certain benefits and what the social welfare is that people should be able to get. And then you can use statistical techniques to try to mathematically prove or to convince others why a certain change should be done. Okay, and so this is not obviously, we're not going to be doing a great deal of statistics in this course. Of this chapter is rather short, but that was why I kind of combined these two chapters together, just to give us an idea, both again from the previous chapter of the theoretical techniques we use in talking about public finance issues, and then here in this chapter, what the statistical techniques are we use to measure the impact of certain changes for both public finance and utility levels.